Algebra 1 skills number 34, completing the square. The purpose of completing the square here. The purpose of it is to change a quadratic in standard form, which means you have no parentheses, to vertex form, where you have one parentheses, and we'll explain the significance. Here are the steps, if you want to write them down. Okay, of course, we'll go over this with examples. Okay, and we'll refer to those steps as we go through the video. Example 1, change the vertex form. So notice this is standard form, no parentheses. And this is going to be easier if you have a 1 in this position and an even number in this position. This is the x squared coefficient, this is the x coefficient. Our first step, if you remember from the previous slide, is to make sure the x squared coefficient is 1, and it is. And in most of these cases, it will be. Our second step is to take half of our x coefficient, which is 8, and square it. So we'll do that here. Notice the color coding. Half of 8 is 4, and 4 squared is 16. We add the 16, the red number, and subtract to the expression. Now, sometimes you'll see an equals in these. You'll see equals 0 here or something. And the way you do it's very, very similar, slight adjustment, but we're just going to leave this with expressions. Now, the first 3 terms will factor. Factors of 16 to add to 8 are 4 and 4. Now, we rigged it that way. How do I know 4 times 4 is 16? Well, that's what we squared it. 4 times 4 is 16. How do I know that 4 plus 4 is 8? Well, we took half of 8. When you take half of something, you're dividing it into 2 equal pieces that add back to that something. So this process here, the purpose of it is to make it factor into the same thing twice. Now, negative 19 is just these two combined. Negative 16 minus 3. Now, since it's x plus 4 twice, I can write it x plus 4 squared. So notice I went to vertex form. No parentheses, standard form, 1 parenthesis, vertex form. Now, what's the purpose of vertex form? Notice the color coding again. Vertex form allows you to easily find the vertex by simply changing the sign in the parentheses and not on the outside. Here's a graph to support that. Negative 4, negative 19 is the vertex of that parabola. Second example, very similar. Again, we have a 1 in this position, so we take half the negative 12, which is negative this time, and square it. And this 36 that we're going to add and subtract to the expression. Again, we factor in what, notice, I didn't say this the first example, but that blue number, negative 6, always shows back up. I didn't say that outright the first example. But we rigged it so that blue number, the half number, comes back up. Negative 6 times negative 6 is positive 36. Negative 6 plus negative 6 is negative 12. So I just chose to immediately write this way this time. Negative 36 minus 21 is negative 57. Okay, so the vertex, again, change the sign and don't change the sign. It's mildly annoying when you have an odd in this position. But again, we have a 1 here, so that's nice. Half of 9 is just 9 over 2. You could say 4.5, but we prefer 9 over 2. And when you square that, just square the top. 9 squared is 81. Square the bottom. 2 squared is 4. We add and subtract 81/4 to the expression. Now here we really want to take advantage of the fact that we know that blue number is going to show back up, because it's hard to factor this. I mean, with the fraction, it's hard to factor. Okay, so that blue number, 9/2, just simply shows back up. Negative 81 over 4 plus 4 over 4 is negative 77 over 4, which you can use a calculator in some cases there. You can see the vertex. Change the sign on the inside and on the outside. Final example, what happens if there's not a 1 in this position? Well, we're going to factor that 2 out. Okay, now we're only going to concentrate inside the parenthesis. We'll worry about the 2 in a minute. So same deal. Take half of 6 and square it. So I didn't write it this time. Half of 6 is 3. 3 squared is 9. So I'm going to add and subtract 9. Okay, I didn't color code or anything this time. Remember, half of 6 is 3, so it shows back up like this. X plus 3 squared. These 3 terms right here makes x plus 3 squared. Negative 9 minus 11 is negative 20. Now we do something a little fancy here. Not really fancy, but we're going to say this. We're going to keep that x plus 3 squared, but we're going to distribute the 2, so it just latches to the front of that, and then 2 times negative 20 is negative 40. Okay, this 2 is going to be something called a vertical stretch that we'll worry about in a future video. But for now, our vertex, again, is negative 3, negative 40. The 2 does not affect the vertex.